right, we're going to be looking at doing a perfectly inelastic collision here where two objects start apart and together. So let's read the problem.
Pat runs at 8 meters per second toward a precipice.
Wait, what is a precipice?
You could use the dictionary there to look up the definition. That's what us old people do.
Okay. Here it is. A very steep or overhanging place.
Pat, who has a mass of 70 kilograms, runs at 8 meters per second toward a precipice and jumps into a 30-kilogram shopping cart sitting at rest. What is the final velocity of Pat and the cart?
That does look like a precipice, but wait, there's a second definition. The brink of disaster.
Pat, who has a mass of 70 kilograms, runs at 8 meters per second toward a precipice and jumps into a 30-kilogram shopping cart sitting at rest. What is the final velocity of the cart and Pat? And will Pat outrun the snake, who has a maximum speed of 5 meters per second and is pissed about Pat stealing his shopping cart?
I think it's both.
I agree, Mr. Rather. This does qualify as both definitions. So this is a perfectly inelastic collision because they start apart and together. When they end together, those two final velocities are going to be the same. And so when I set up my list here, I have Pat at 70 kilograms, the cart at 30 kilograms. Pat was originally moving at 8 meters per second, and the cart was originally moving at 0. Now, that 8 meters per second was in the X direction. Yes, when Pat jumps, he is moving in the Y direction, but we're only talking about momentum conservation in the X direction here. And so if you remember back to projectile motion, the velocity in the X direction doesn't change as they fly through the air. All right. And because they end together, we will know these two final velocities will be the same. So when we set up our conservation of momentum equation, the momentum before is equal to the momentum afterwards, we are going to go ahead and combine those two masses afterwards. And now we're up to solving. So anything that's 0 will cross out. So the cart originally is stopped. And so now I can just divide the m1 plus m2 and plug in my numbers. So 70 times positive 8, all divided by 70 plus 30, gives me the final velocity of both Pat and the cart, which comes out to be 5.6 meters per second.
So you could say Pat was successful.
Yes, but it's not the evergreen way to steal, even from a snake in possession of a shopping cart.
True. Evergreens do what's right, care for everyone, and embrace excellence. I'm sure Pat will return the shopping cart upon learning of the snake's legal possession of the shopping cart in question.